This is section 7.2. We're going to be dealing with verifying trig identities. So the first thing I want to look at is this gray box here that deals with some strategies for verifying identities. So the first strategy is just simply to learn the fundamental identities. You had the quotient identities, the reciprocal identities, and the Pythagorean identities. So all of these need to be, you need to be very familiar with all of these. For example, we know that sine squared of theta is equal to 1 minus cosine squared of theta. We've seen that before because we know it's an alternate form of sine squared of theta plus cosine squared theta is equal to 1. So being able to recognize any of the different forms of the identities plus the identities themselves. Secondly, the next hint is to try to rewrite the more complicated side and make it look like the simpler side. So start with a side that looks more complicated. Number 3. Sometimes it's helpful to put all of your functions in terms of sine and cosine and then simplify. Not always, but a lot of times it's easier to work with sines and cosines. 4, if there is any factoring to be done, be comfortable with factoring. You guys have done factoring since your high school days. So when you're looking at something like this trinomial, we know that it factors to x plus y quantity squared. So, or the x squared minus y squared is the difference of two perfect squares. You know that that's x plus y times x minus y. So just being comfortable with factoring and factoring when necessary. And here's an example of that. If you saw sine squared of x plus 2 sine of x plus 1, this can be factored by using, again, this concept right here. So factor when you can. Also, not only can we use factoring, but we can just use our basic algebra skills. Maybe that's going to be adding and subtracting fractions. Maybe that will be getting a common denominator or dividing fractions or multiplying or substituting. All of these are just common algebraic concepts that you've been learning for years and years and years. And so the next example I want to kind of run through with you is where we're going to add two fractions. So you know that if we're going to add two fractions together, we do this by getting a common denominator. Well, my common denominator here is going to be sine of theta times cosine of theta. So what we'll do, as you well know, is we'll take the first fraction and multiply by the number 1, cosine over cosine. Add to that the second fraction, will again multiply by the number 1. In this case will be sine over sine of theta over sine of theta. So we're using the least common denominator here. And then what we will do is our common denominator is now sine times cosine, and our new numerator is going to be cosine of theta plus sine of theta. So that's just adding two fractions together, remembering what it is to add fractions. Number 5, when you are using substitutions, just remember what the goal is. And this is not even just necessarily for substitutions. This is for any of the math that you're doing. Keep an eye on what the other side looks like. You're trying to change one side into another side. So keep reminding yourself of what you're trying to get to. And then lastly, if you have an expression that contains something like 1 plus sine of x, this looks a whole lot like maybe sine squared minus 1 or 1 minus sine squared. But the thing is it's missing those squares. So what could we do then? We could use conjugates. And so if I took 1 plus sine and multiply by its conjugate, 1 minus sine, then I'm going to get 1 minus sine squared. And this is something that I can use with my Pythagorean identities. And then 1 minus sine squared can always be replaced then, sorry about that, can always be replaced by cosine squared. And you could do this for any of the ones that look like Pythagorean identities. 1 minus sine of x, 1 plus cosine of x. Some other examples might be 1 plus tangent of x or secant of x minus 1. All of these are almost Pythagorean identities. All that's missing is the squares. So if it looks like a Pythagorean identity but it's missing the squares, you might be able to use conjugates. All right, so the very first thing here that we're going to look at before we deal with example number 1, to avoid the temptation to use algebraic properties, one thing that you can do is just simply to work on one side and try to match it to the other side. This is not always going to be our strategy, but this is a possible strategy. All right, so we have here the left side. We're told that the left side, secant times the quantity sine plus cosine, is equal to 1 plus tangent. Now, ask yourself which side looks more complicated. So I would say probably the left side looks more complicated. So what we're going to do first is we're going to distribute. So we know how to do that. So let's distribute. But when I distribute, I'm also going to use the idea that we can turn things into sines and cosines. So instead of distributing a secant of theta, I'm going to distribute a 1 over cosine of theta. And so, and I like to give reasons for each step. So the very first thing I'm going to do is distribute. And I'm going to use that reciprocal identity of 1 over cosine of theta. So that'll be 1 over cosine times sine. And then for the second side, or the second distribution, 1 over cosine times cosine. Well, now what we want to do then is just simplify. So my first fraction is going to be sine over cosine, and my second fraction is going to be 1. And then remind yourself, look over at the other side. Where is it that we're trying to go? And all of a sudden, you should be able to see that we're really close to that. And so the very last thing that we'll do then, we'll use that quotient identity and turn our sine into a sine over cosine into tangent. And all of a sudden, I've made the left side match the right side. They're not quite identical. There is the commutative property, the order is switched, but if that's all that's lacking, then it's identical enough. All right, well then let's look at example number 2. Once again, I could use distribution. And so the very first thing is we'll go ahead and take our cotangent squared and multiply it by the tangent squared. And then distribute to both pieces. All right, so the next thing that we will do is think about these two right here. These guys are reciprocals of each other. So when I take a pair of reciprocals and multiply them by each other, think about what is always going to come out. And so when I multiply these reciprocals, I'm going to get 1. I just copied down the cotangent squared. But 1 plus cotangent squared is going to be the same thing by the Pythagorean identity as cosecant squared, which is matching the other side. All right, let's look at example number 3. So you might ask, well, which side is more complicated than the other side? And maybe you don't know. And so when you don't know, just pick a side. So I'm going to start with the left side here. And I'm going to change everything into sines and cosines. Okay, so by doing that then, I'm going to be using, for tangent squared, I will be using the quotient identity, and for secant squared, I'll be using the reciprocal identity. Okay, well now this is dividing two fractions, and so the next thing that we'll do is we'll drop, change, flip, keep, change, flip, multiply by the reciprocal, invert and multiply, whatever it is that you've learned through the years, but we are dividing fractions. Notice at this point that cosine squared on top and cosine squared on bottom will cancel each other out. So now I'm only left with sine squared. Okay, but the problem is that sine squared does not match the other side. Now, I'm just going to be very transparent with you. At this point, I know that the directions say I'm working with one side, but I kind of got stuck. And it's okay to get stuck. So what I decided to do, and I didn't write this down, so I'm going to write it down here in the video. What I decided to do was I was like, let's go ahead and FOIL the other side. And so first is going to be 1. Outers and inners are going to zero each other out. And then the last will be 1 minus, it'll be a minus cosine squared of t. And all of a sudden I was like, oh, that's a Pythagorean identity. That's the same thing as sine squared. So then what I did next is instead of working on the right-hand side, I just brought that over to the left-hand side. Sine squared is the same thing as 1 minus cosine squared because of the Pythagorean identity. And then because of the work that I just got finished doing here, I went ahead and factored that 1 minus cosine squared. It's a difference of two perfect squares. So that gave me my 1 minus cosine times 1 plus cosine. And then at that point, I don't even need what was written on the other side anymore because it helped me to work backwards. All right, for the next example, number 4, I mentioned this just a few moments ago. If a phrase looks almost like a Pythagorean identity, but it's missing the squares, then conjugates can be used. So what I'd like to point out here is this guy, it actually looks almost like a Pythagorean identity. This one, the rearranged version, would be secant squared minus tangent squared is equal to 1. So since it almost looks like a Pythagorean, we will use our conjugates for that. All right, so let's multiply by the top and the bottom by the conjugate. So that's going to be secant plus tangent all over secant plus tangent. This is legal because it's just equal to the value of 1. All right, so then next we will go ahead and multiply on top and multiply on bottom. Now, notice that when I multiplied on top, I didn't actually distribute. I'll decide if I need to distribute in a bit, but for now, I'm just going to leave it alone. But then on bottom, when I multiplied, I got that Pythagorean identity that I wanted so badly, that secant squared minus tangent squared. So then the next thing that I'll do is I'll take the bottom and I'm going to go ahead and substitute my Pythagorean identity. Now there's going to be a little bit of extra here when I uncover it, but secant squared minus tangent squared is equal to the number 1. So this guy is being substituted by the number 1. And you say, well, where did that sign come from? All right, so take a look. Remember I said that you always want to look at your goal. Remember where you're trying to go. And when I compare this with what I already have, I like that this over here matches this. I don't want the cosecant to be there. It's in the way. So what I did was I got the reciprocal of cosecant, which is 1 over sine. And so that's why I put my sign on the bottom. So that came from the reciprocal identity. And then that left me with just what I wanted on top. And now you'll notice that this, with the exception of the times 1, matches the other side. So I was able to match the two sides. All right, verifying identities by working on both sides. So I actually kind of showed you this a little bit ago, but instead of just working on the other side to work backwards, what this means is that I'm going to work on one side until I get stuck. And then I'm going to go to the other side and I'm going to work until I get stuck. And what I'm hoping for is that when I get stuck, the two bottom lines are going to end up being the same thing. So that's going to be the goal here. All right, now I couldn't really tell which side was more complicated than the other side. And so for this one, I just decided to go ahead and start on the left. And there's multiple things that I could have done. I could have used conjugates, and I could have started on the right and used factoring. But what I decided to do was I decided to change the left side into all sines and cosines. All right, so I used the reciprocal and the quotient identities. So on top, that's cotangent is cosine over sine minus cosecant, which is 1 over sine. And then on bottom, I did the same thing. All right, so then the next thing that I did was I got a common denominator on top and a common denominator on bottom, which it was already there for me. Okay, so I'm just going to simply combine my fractions, add and subtract fractions. So on top, it'll be cosine minus 1 all over sine. And on bottom, cosine plus 1 all over sine. Okay, so then the next thing that I'm going to do is I'm dividing two fractions. So I know that the way I divide fractions is to multiply by the reciprocal. So I'm going to take the top, leave it alone, get the reciprocal of the bottom, and multiply. You'll notice at this point that the sign on top and the sign on bottom will cancel each other out. And so what I have left at that point is cosine alpha minus 1 all over cosine alpha plus 1. And I got that just by simplifying. Now, unfortunately, as I'm looking at what I need to turn my left side into, it doesn't seem to be anywhere close to what I have. So I'm stuck at this point. There's not really a whole lot that I can do. So what I am going to do is I'm going to go over to the other side now, and I'm just going to start working on the left side. And I notice that the top can be factored. Okay, so we'll use our factoring. And the top is going to be 1 minus cosine alpha quantity squared. The bottom, for now, I'm just going to use the Pythagorean identity. And the reason I am is because the bottom had a sine squared in it, but I want cosines. So I turned my sine squared into a 1 minus cosine squared. For now, the negative is just a tag along. Well, then I kind of expanded things out. And so on top, I just wrote my factor twice since it was a repeated factor. But on bottom, I used the difference of squares. So that's 1 minus cosine times 1 plus cosine. And I noticed then that I could cancel the two identical factors. Now, before I move any further, let's go remind ourselves of where we are. And I can see that I'm getting really, really close to where I want to be. In fact, the bottom without the negative is identical to the bottom of what I had before. So what I'm going to do then is that negative that I have, I'm going to move it to the top. That's totally legal. And I'm going to distribute it to my top, to my numerator, and leave the denominator alone because the denominators are already matching. So moving it to the top, leaving the bottom alone, and then we go ahead and distribute. And now I can see that my tops are matching as well. They are written in a different order, but they are exactly the same thing, a -1 and a positive cosine of alpha. So we would say that, yeah, I've been able to change it to the other side. Now, I just wanted to show you, I'm not going to go through the work on this, but I actually did example 5 a second time, and I did it completely differently than I did it the first time. I used conjugates. So what I would say is pause the video and work through each one of these steps line by line. See if it's something that you can do on your own. Both of these ways are just fine. It's not working on both sides, but it is valid, just like the other one is. Okay, now that we are back, I wanted to show you some examples. So I'm not going to go through all the work on these. Basically, what I would suggest is to pause the video, write down the example, try to work it out on your own, and then play the video so that you can uncover the answers. So I would go ahead and pause the video. And now that you're back, I'm going to uncover the answers. And so, like I said, I'm not going to take the time to walk through the work, but you can do that on your own. So that's example number 1. Here's example number 2. You might want to pause the video. And uncovering. On this one, I worked on both sides. All right, pause the video again for example number 3. And at your back, so let's go ahead then and uncover. And again, I've placed my reasons there so that hopefully you can see what I've done. And then we have example number 4. You may want to pause. And one more time, example number 5. So pause the video, see if you can work this one on your own. And see if you got that. Okay, if you would like some more examples, if this just isn't enough, in your My Lab account, go to the e-text. you'll go to the homework section in 7.2 in this particular section, and there are tons more examples, more than probably you could work out. I'm talking a whole lot. Specifically, I would suggest, especially starting with number 45, and really, oh goodness, that whole section goes to number 88. So you can see there that there is plenty of examples that you can work over and over again.